What if your specifications didn't just guide your code, they actually generated it? That's the promise of spec-driven development, and it's the methodology GitHub is betting big on right now. If you use AI to help you code, your workflow probably looks something like this. You describe what you want, the AI writes some code, you review it, spot a problem, ask for a fix, and repeat. The code is what you touch. The code is what you review and commit. Everything else, requirements, design decisions, acceptance criteria, lives and documents that the code is supposed to reflect. But they rarely stay in sync. This isn't a failure of discipline, it's a structural problem. When code is the source of truth, specifications become scaffolding, useful while you build, then discarded once the real work begins. Spec-driven development flips this entirely. Instead of specifications serving code, code serves specifications. The product requirements document isn't a guide for implementation. It's the source that generates implementation. Technical plans aren't documents that inform coding, they're precise definitions that produce code. When specifications generate code, there's no gap, only transformation. Maintaining software means evolving specifications. Debugging means fixing the spec that produced incorrect code. Refactoring means restructuring the specification for clarity. Three trends converge to make this practical now. First, AI reached a capability threshold. Natural language specifications can now reliably generate working code. Second, software complexity grew exponential. Modern systems integrate dozens of services and dependencies. Keeping everything aligned through manual processes is increasingly impossible. Third, the pace of change accelerated. Requirements change far more rapidly today than ever before. Pivoting isn't exceptional, it's expected. So what does the workflow actually look like? You start with an idea, often vague and incomplete. Through iterative conversation with AI, this becomes a comprehensive product requirements document. The AI asks clarifying questions, identifies edge cases, and helps define precise acceptance criteria. From that PRD, AI generates implementation plans that map requirements to technical decisions. Every technology choice has documented rationale. Every architectural decision traces back to specific requirements. Then code generation begins, domain concepts become data models, user stories become API endpoints, acceptance scenarios become tests. Testing isn't written after code, it's part of the specification that generates both. And here's the powerful part. Production metrics and incidents don't just trigger hotfixes. They update specifications for the next regeneration. Performance bottlenecks become new requirements. Security vulnerabilities become constraints that affect everything going forward. GitHub has released a toolkit called Spec Kit that makes this concrete. 3 commands, 15 minutes, and you have a complete feature specification, a detailed implementation plan, and an executable task list. The traditional approach would take 12 hours of documentation work. The real power isn't just automation. It's how the templates constrain AI behavior toward higher quality output. The specification template prevents premature implementation details. It forces explicit uncertainty markers. Instead of guessing, the AI must flag ambiguities. And it includes structured self-review checklists that act like unit tests for your specification. At the heart of all this is a constitution, a set of principles that govern how specifications become code. Library first design, test first imperative, simplicity and anti-abstraction. These principles are immutable. Code generated today follows the same rules as code generated next year. You don't need to overhaul your workflow to try this. Start with one feature. Write a simple constitution. Treat the spec as the source of truth. When you find a bug, ask yourself, is this a spec problem or an implementation problem? If the spec is correct and the code is wrong, regenerate. If the spec is wrong, fix the spec and regenerate. The gap between what you want and what the code does is the single biggest source of friction in AI-assisted development. Spec-driven development eliminates that gap by making the specification the source of truth. This isn't about replacing developers or automating creativity. It's about amplifying human capability by automating the mechanical translation between intent and implementation. Code becomes the output, not the input, and that changes everything.